I'm going to do is go over the Blue Book sample questions so that you guys are comfortable with the Desmos calculator here. Some of these, obviously, like number 12 here, don't require a calculator. So, like the limit from 1 to the right is just going to be 2. You could just call it a day, right? Yippee, hooray. Now, this one here, where we use a calculator, notice how here I could just click on this and that's going to zoom into the calculator and expand it. But we have the velocity. Anytime I see an equation, what you guys are going to do is probably type that exact equation into the um, Desmos. And then it's asking us what's the acceleration of the particle at time t is equal to 1.2. Now, obviously, Desmos will not know that the connection between velocity and acceleration, so you can't just say a 1.2 and call it a day, and you can't say that on that for Q either. But remember that because we want to find the acceleration, we could take the derivative of velocity at 1.2, and that will give us an answer. In this case, I messed something up. Let's see. 1.3t. Oh, that should be a 0.4. How embarrassing. Anyways, that's going to give us our answer of C. Now, likewise, this one right here might not require a table. The graphing calculator, but it might be helpful if you want to visualize what's happening. But then again, remember, there are some restrictions here whenever we are looking at this. So we want to figure out which of the following statements must be true given that this is f prime of x, f is twice differentiable, and we have all of this right here. So it says f is increasing from -1 to 5. Now, if f is increasing, this means that my derivative is positive. Now, as you guys look at this, yes, all my derivatives are positive, except remember that because f is twice differentiable, this means that f prime is differentiable, which means that f prime is continuous on this interval. And since f prime is continuous, I don't know what's happening between -1 and 0. So what might happen is at -0.6 or -0.5, that might be -3. And in this case, f will not be increasing from -1 to 5 because then we know that we are decreasing somewhere here. Same thing with part B. Whenever it's talking about the graph of f is concave down for 1 to 5, this tells me that my derivative is decreasing. Once again, it looks like my derivative is decreasing. Yes. However, once again, if I say something like -0.5, and this is 14, we are increasing, and then we are decreasing. So then that's not going to help us. So B isn't going to work. C, there exists a value C from -1 to 5 such that f prime of C is equal to -3/2. Now, we are given f prime of x, so we are using the intermediate value theorem. F is twice differentiable, so f is differentiable, which means that f is continuous. So, because f is continuous, looking at 11, 9, 8, 5, and 2, there's no way I could hit -3/2 based off of this information alone. Yes, hypothetically, I could say -0.5 is like -2. However, we don't know if -0.5 is actually -2 or not. But based off of this information alone, and if I were to make like a little line right here, notice how here I'm not crossing -3/2, so C doesn't work. Now the last one, there exists a value of C from -1 to 5 such that f double prime of C is equal to -3/2. This one right here uses MVT, and remember that the conditions for the mean value theorem is that, in this case, because we are trying to find f double prime of c, is that f prime is differentiable, therefore f prime is continuous. We know that's true because f is a twice differentiable function. If they did not give us this right here, then we'll be screwed because we won't know if f is continuous or not. Speaking about that, notice how if I highlighted this, you have the option to underline and you have the option to highlight. Also, one more thing, you also, if you click on this, you have the option to cross out the answer choices. So very similar to the pre-ACT, ACT, SAT. So what we've been doing, what you guys have been doing, whenever you guys are taking your standardized assessments. But now, again, back to the problem. We have verified that MVT works. So now I could just verify that if I have f prime of 5 minus f prime of -1 all over 5 minus -1, that's going to work. Obviously, the calculator doesn't speak f prime of 5 and it doesn't speak f prime of -1, so you'll actually have to find out and type out and replace the value of f prime of 5 being 2 and f prime of -1 being 11. That gives us our average rate of change being -3/2. So that's why here our answer is D. Another tips and tricks, once again, I can have a line here just so that you guys can look at it and pretend that it's continuous. If it's just like that, might be helpful for IVT or something like that. Also, one more thing, if I were to hypothetically go to the next page, notice how the calculator is still on the screen. It doesn't go away. Also, if I were to press X right here and I accidentally press it, and I press my calculator, the stuff will still appear here. So nothing will get erased. Let's see. You can highlight. You already know that. You can also make a note. You could also hide the note. You can also move the MCQ in the problem if you want to focus more on the problem or the answer choices. So just play around with it. You should understand what's happening, right? Yeah. I'm gonna go ahead and erase that. 15 says let f be the function with the derivative defined by this lovely thing. How many points of inflection does the graph of f have on the interval from 0 to 9? Now, plot twist, if you type in that exact thing right here, you'll notice that it doesn't speak derivative language right here because I don't know what f of x is. Now, I don't want to write f of x because technically this is an f of x. This is f prime of x. So instead of confusing you guys, you should probably do another variable like g, and just remember that this g right here represents the derivative of f. So that now, whenever you have that, you could take the derivative of this because we're trying to find the points of inflections here. Obviously, this looks messy, right? You could go ahead using your basic Desmos thing, hide the graph, and look at the answer choices. Here it's asking us how many points of inflections we have from 0 to 9. So using your scale, go from 0 to 9 and then find out how many times it crosses 0. In this case, we have 4 times. So our answer choice here is D. (16) We have honey being poured through the funnel at a rate of R of t. So I'm going to type in R of t is equal to 4e negative 0.05 t. Notice how it grabs it for us. That's great. Yippee, hooray. Another thing to note here is hypothetically, if this was negative 0.35 t plus 2, and I say plus 2, you'll notice that it's going to be on the outside. We don't want that because we want that as an exponent if we were hypothetically saying negative 0.035 t plus 2. So Just make sure that you have parentheses around that if you have more than two terms, or just erase the two and then just move it back up. Oops, guess you can't do that. So you'll actually have to um, use parentheses. Now, since I have already defined R of t on the calculator, and it's asking us how many ounces of honey are poured through the funnel from time t is equal to 0 to time t is equal to 3, I could use the integral from 0 to 3 of R of t dt, and that's going to give me my answer of 54.8. Oops, what did I do wrong? Oh, duh, we don't need a plus 2. That's going to give us our answer of 7.2429. All right, those were the MCQ in terms of the active questions on Blue Book. Notice how the calculator is still up there, so I'm going to go ahead and X that out. I'm going to go ahead and click Next. You'll have your little break between the MCQ and FRQ. Then, once again, here are the instructions on the FRQ. Notice how here this is calculator active. Make sure that your calculator is in degree mode. Read all of this, it's all important. It's very, 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 very important, especially on the calculator active questions, that whenever you are entering your questions, you always, always, always indicate the setup of your question on your FRQ booklet. Another thing is, don't use calculator speak, so don't write down what you might have written on Desmos in terms of calculator speak. We don't want that. So, here is the question that we'll be going over. Notice how here you have the stimulus, and then you have the questions on the right. You have all 4 questions on the right. You will not type anything up on the FRQ. There's no typing here, unlike other exams. Here, you guys are just gonna look at the questions and write your answers on your FRQ booklet. So like here, you'll write your answers in the free response booklet. All right, so we have a certain weekday. The rates at which vehicles cross a bridge is mod by the differentiable function r from 0 to 12, where r of t is measured in vehicles per hour, and t is the number of hours since 7 a.m. Values of r of t for selected values of t are given in the table. Part A says approximate r prime of 5 using the average rate of r over the interval 4 to 6. Show the computations that lead to our answer. Use correct units to explain the meaning of r prime of 5 in the context of the problem. So, I'm going to go ahead and find the average rate of change using 4 to 6. Now, this right here is acceptable on the AP exam whenever you are writing this on your FRQ booklet. You have a quotient and you have a difference. So they like that for your first part. And then what you guys are going to do is go ahead and substitute in R of 6 and R4. So we get negative 216. Now, if you write this right here and only this, they'll give you full credit because technically this is a numerical answer. If you say negative 216, then you need either this right here or this right here, aka your supporting work for negative 216. So that's going to be like your first point. I don't know the breakdown of this, but we're going to pretend that's your first point. It says, using correct units, explain the meaning of r prime of 5 in the context of the problem. So notice how r of t is vehicles per hour. So this is already a rate. So this is like saying the first derivative. If I have r prime of 5, this is saying the second derivative, or in this case, the first derivative of the derivative of the derivative. And because this is already a derivative, then my units should be vehicles per hour per hour. Now, on the AP exam, whenever it's asking you to explain this in the context of the problem, what you should probably say is the rate at which vehicles cross a bridge from 7 a.m. to 7 p.m. Or you could say time t is equal to 0 to time t is equal to 12 is decreasing at a rate of 216 vehicles per hour per hour. And that will be your little context right there. Remember that whenever you're writing the context of a problem, you need a couple of things. You need the noun, aka the context. You need the time from t is equal to 0 to t is equal to 12. And then you also need your rate. In this case, we have decreasing at a rate of 216 vehicles per hour per hour. Okay, you would do that for part A. For part B, we want a midpoint sum with 3 subintervals of equal length indicated by the data in the table. And we want to approximate the value of 0 to 12, indicate units of measure. Once again, you want to show the setup. You want to show the work. You will always get at least 1 point for the setup, even though it might be wrong. At least 5 of the 6 terms needs to be correct to get the Riemann sum setup. So here, since I want a midpoint, notice how here I'm going to go from 0 to 4, which is 4, and since it's a midpoint, I'm using R of 2, so 3653. Ooh, excuse me. Then I'm going from 4 to 8, and that's going to be 3010 using R of 6. And then I'm going to go from 4 again, from 8 to 12, and then using 10, 1986. And then you would just write all of this in the FRQ booklet. And if you want to write 34,596, that's fine, but they'll give you both points here. You'll get the Riemann sum point, and you'll get the answer point here. Now, if you did something wrong and you said 2201, you'll probably get the Riemann sum point, but not the answer point. It also told you to indicate units of measure. So here, this would just be vehicles because we are integrating. That might be a point, or that point might be embedded with the Riemann sum point. Like I said, I don't know what the scoring guideline is, so do not trust me anything on points for this particular FRQ. Sorry, guys. Okay, for C, we have on a certain weekend day, the rate at which vehicles cross the bridge is multiplied by h of t. So I'm going to go ahead and type in h of t in my calculator for 0 to 17, where h of t is measured in vehicles per hour and t is the number of hours at 7 a.m. According to this model, what is the average number of vehicles crossing the bridge per hour on the weekend day for 0 to 12? Notice how h of t is a rate already, just like how r of t is a rate. And we want to find out the average number of vehicles, so we have to integrate. But since it's asking us the average number of vehicles, we want to use the average value formula, so I need 1 over 12, integral 0 to 12 of h of t dt. And that's going to give us 2,452 vehicles. So you'll need this right here, your setup, and then this right here, your answer. Now, if you want to put negative t cubed minus 3t squared plus 288t plus 1300 in the integrand, you can, but just please make sure that whenever you put it in the integrand that you have parentheses around it, because if you don't, Desmos will not like that. So make sure you guys put the integrand in parentheses so you have 2,452. Now on the AP exam, like I said, this would be correct because they have already given you and labeled h of t, because that's labeled for you and given to you. Just over the semester, whenever we've been doing FRQs, I've been telling you that if you're going to shorthand something, always label it so that the AP graders know what you're talking about. Okay. For part D, we have 12 to 17, and we want to find the local linear approximation to the function h in part C at time t is equal to 12 is a better model for the rate at which vehicles cross the bridge on the weekend day. Use L of t to find the time t for 12 to 17 at which the rate of vehicles crossing the bridge is 2,000 vehicles per hour. Show the work that leads to your answer. So remember that I need two things if I want a local linear approximation. I need a point and I need a slope. Here, since we are finding the local approximation to h, this is going to be my function right here. So I need a point at 12, which is going to be 2,596. And then I need the slope at 12, which is going to give me negative 216. All right, so we have my point, we have my slope, so I'm going to go ahead and use my little point slope form. Whenever you guys are using point slope form, please make sure that your variables are in terms of what they give you. So in this case, we want L and we want T. Don't give me Y and X here. So I want L minus 2,596 is equal to negative 216, t minus 12 for your linear approximation. So you'll have to write this on your booklet. You'll have to write this on your booklet. You'll have to write this on your booklet. And then the question is asking us at what rates of the vehicles crossing the bridge is 2,000 vehicles per hour. This right here is also a rate because remember that h of t is a rate, vehicles per hour. Now, what you guys can do here is substitute in 2,000 for L and see what you get whenever you substitute it in. One thing that they don't like is t, so probably use x and then find out where that thing is right there. In this case, this tells me that my x value slash t value is 14.75926. Now, that makes sense in context of our problem because it's between 12 and 17. So also think about that in terms of your critical thinking skills to see if it's within our domain. Another way that we could do this is use y and x here so that we could graph it, but on the FRQ booklet use O and T. And then you guys can also graph 2,000 and find the intersection there. To find the intersection, you have to make sure that your scale is from 12 to 17 here, aka your domain. And then your y-axis, because we want 2,000, it might make sense to go from 1900 to 2100 and see what happens there. And then you'll see once again you'll get 14.75926. Excuse me. As always, make sure that you are using 3 decimal places, at least 3 decimal places, whenever you guys are doing your FRQ. So your time t would be 14.759. In this case, t's in hours, but you don't have to express units there. Once you're done with the active section, you'll probably sit pretty, and then you'll have the inactive section. One thing that is important, though, unlike the paper tests from years ago, is that usually whenever we are done with the active portion, you still have the stimulus and you could still work on the active portion without using the calculator. But on the exam in May, because it's online and your stimulus is online, you won't be able to see the questions on after you have submitted part A of your FRQ. Meaning that if you want to work on it, you really can't because you don't know what the questions are. So that's that. So you can't go back to part A once you're in part B here. Of course, once again, just read all of this. Since this is calculator inactive, I'm not going to go over this because it doesn't really use Desmos. But of course, just play around with the Blue Book app so that you're comfortable with it by May. And then by April, hopefully I could cook up another tips and tricks on using Desmos. But of course, remember that you still have the option to use your TI-84 if you don't want to use Desmos. There are some pros and cons on using the 84 and Desmos, and I'll probably, explain whenever April hits.